Hey guys, my name is Aarit, and here's my presentation for Project 2. So just a brief overview of what this project was. We had to suggest improvements to a product that we use, describe that product, describe the problem, the suggestion with some sketches in detailed CAD, then the manufacturing and materials needed to actually make the product, and then the advantages and disadvantages of our improvement. So what was my product? Well, it was the very chairs in our classroom. So the picture on the right is what we have. I've included the picture on the left just because it's a bit higher quality. And here are my problems with it. So I kind of have three main problems. One is that the desk is just too small. Two, it has that ledge that you see in the leftmost picture in my orange circle. And then three, the bottom tray is kind of space inefficient, which is what my third picture is kind of describing. But I'll go into more detail here in the next few slides. So here's my issue with the ledge. So as you can see in the top drawing, there is kind of just a straight rectangular edge at the front of the table. And so I don't like this because it kind of blocks your movement. Now, of course, the ledge is preventing you from pushing things over the edge, but I have an iPad, which you can see in this left picture, and you can see that my iPad takes up most of the desk, so I like to push the case of my iPad over the edge. However, because there's a ledge, it's just kind of hard to do. That's why I'm proposing a ramp, because the ramp will allow me to gradually push my iPad up the ramp and then over the ledge. That way I'm still mindful that I'm at the edge and that I don't push anything off of it, but the ramp won't limit my movement the same way that the current ledge does. And like I said, the desk is just too small, so I've made it only a little bit wider, but much deeper, about by 50%. And then the base. So the circular shape is just space inefficient, and so you can see on the left that it's 28 inches wide, yet my implementation is much narrower, 4 inches narrower. Yet even with that, there's actually more area with my implementation. And that's simply because a rectangle has more area for the same kind of footprints as a circle. So I wanted to make it more space efficient so that we could have, so that these desks just take up less space overall. And here's what those ideas really look like in a detailed CAD. So here you can see the ramp, and yeah, it's kind of self-explanatory. It'll allow me to push things a little bit over the edge, but it won't completely hinder my movement the same way the current ledge does. However, it still maintains the functionality of the current ledge. And of course, I've made the workspace much longer. In fact, it adds about 63% more area. Continuing on with the base, so you can see that it's now a rectangular shape. It's almost a square, but yeah, like I said, it gives us more area, even though that extra space isn't really needed because no one actually uses that space, not that I've seen. But it's more space efficient because it's much narrower and also not as deep. One thing I wanted to point out was the fifth wheel that I've added. It's in the blue circle at the bottom. And I added a fifth wheel not because it was necessary, but because it adds stability. So the circular shape is very stable, but if you imagine a chair that has 4 legs, it's pretty easy to tip back. So I added a fifth wheel so that you won't tip back and you have kind of the same stability as the existing circular product. And here's what that all looks like together. It looks pretty similar to the current desk, but it has some minor changes that are pretty meaningful to me. Now, design for X. So this was designed for manufacturing in mind because I saw actually on a window manufacturer's website that making circular shapes is actually harder than rectangular shapes. They were pointing out that it's just easier to make a straight edge versus a curve. Similarly, the rectangular shape is designed for storage and assembly in mind because, like I described, it'll give us more area down there, which is helpful because our class It has a lot of these desks in the back where I sit, and so sometimes when they get just crunched together, they take up a lot of space. So in a tight setting like our classroom, the narrower desks will be better for storage. Also, I figured that a straight edge would just be easier to package and transport, and then it's easier for the person who's assembling it to handle the rectangular shape versus the circular shape. So some advantages. I've already described most of these, but again, the rectangular shape is just overall easier. It's easier to assemble, package, and of course it gives us more area. That's kind of what this picture is showing, that for a circle and a square with the same area, the square takes up less space. Also, going back to the ledge that I'm proposing still has the same functionality as the current ledge, but it'll be easier for me, and a lot of my classmates have said the same thing, so it'll be easier for all of us to use. And of course, a bigger workspace is just going to be easier to use during tests, because some of my classmates have also said, that the desks just don't have enough space, so of course a bigger desktop is much easier to use. So disadvantages is that this whole thing is just going to use more material. So more material is going to be a higher cost, but I don't think that would be a big concern, just because these are actually surprisingly expensive. They're like $200-300, even more. So I don't think the extra cost will be a big deal. The manufacturing processes. So most of this is made out of plastic, so that'll be made with injection molding, which I'll describe here in a second. And then the arm is made out of metal, which will be used, which will be made using metal extrusion. So injection molding is kind of what it sounds like. You put hot plastic into a mold, and then your final product looks like that mold. And then metal extrusion is pretty similar. You push the metal through the die, and then your final product looks like what's in the die. I found this out just because I looked at the website of an existing chair manufacturer, and they do pretty much that. I also found the materials from them, which is polypropylene for most of those plastic products, and then the wheels are just regular caster wheels, which tend to be made out of nylon, so I'm just going to keep those materials the same. And similarly, they used iron for the arm, so I'm just going to use what's already out there. And yeah, that's pretty much it. Thank you for watching. Here are the resources that I use, and the takeaways that I just wanted to improve those 3 things, so hopefully I did. Anyways, thank you for watching. Hopefully that was informational. Hopefully you liked it, and